Okay, so far it's worked out really well to tackle these in twos, and we're going to continue with that because this also just so happens to work out really well to be another question that works out well in twos. So we'll do 7 and 8 real quick. In 7, first of all, we should talk about where it came from. This came from 4.3. 4.3 had 2 days of notes. This is the part that's about angles of rotation. Here's what we've got going on here. We have, these are all in degrees, which is super nice. We made 1 full revolution. That's 360. And then, according to this, we went an extra 140 around again. And that made 500. Now, remember reference angles. Reference are acute, sorry about Lena in the background, and positive, and they are formed with the x-axis. So in terms of here, my reference angle would start here and go to the x-axis. So we're talking about this angle. I'll do it as a double. No idea which is barking. My guess is the UPS guy or something just drove by. Anyway, so this 140, if we would go all the way around, it'd be 180, right? But we didn't get all the way to 180. It was only 140 of the way. So we can think of our reference angle here as being those 40 degrees that we didn't get to. In the next one, we went all the way around. So that's 360. The 70 is the part we didn't do, which means that this little baby piece right here must be 20 degrees more for a total of 380 for this particular angle. Right? The reference angle goes to the x-axis, so we're talking about this part. In this case, the reference angle is just those extra 20 degrees, right? We didn't do a full 90, 70 of them were left unrotated, if we want to say it like that, and so on. And then in this next one, we'll break this one up because we didn't actually get all the way around. So this was 90. This was another 90. This was 90. And then that little bit more was 40. So that's 310. The interesting thing here is we started going down, and so that's why it's a negative 310. Our reference angle, though, is always acute and positive. It's coming down to the x-axis. I'll do double arrows to show you. So this reference angle, remember every quadrant is 90, right? Each quadrant is 90 degrees. So 40 degrees part of the rotated part, that leaves 50 degrees for our reference angle. Okay. Question 8 sort of continues in that 4.3 vibe, but this one is all about the coordinate plane. We took notes on it. We've got that example. We did a yellow worksheet. I think it was yellow, although I'm not good with colors. Could have been orange. We know that this is x, this is y. We also know that we had a key formula for r. So that's going to be helpful to us. So in this particular problem, we're going to do the square root of negative 3 squared plus 4 squared. Hopefully your brain is starting to realize that if you see 3 and 4 in terms of oh my gosh, words hard. If you see 3 and 4 in terms of like 2 parts and you're about to square them and whatnot, your answer is going to be a 5. Now, sine used to be O and H, now it's y over r. Cosine is x over r. And tangent is y over x, because it's sine over cosine. Cosecant then is r over y. Secant is r over x. And cotangent is x over y. Now that we have those came right from our notes, we can just plug in what we know. 4/5, negative 3/5, 4 over negative 3, 5/4, 5 over negative 3, and negative 3 over 4. Right? So having those kind of what's been written in purple a lot is kind of stuff that came from your notes. Make sure you've got that stuff in your notes because you can use your notes tomorrow.